Hello, everyone, and welcome to today's D-Zone webinar with Traversal. Today's topic, self-driving production. AI wrote your code, AI can fix it too. I'm Caleb Kinchlow, and I'll be your host for today's session. Now, before we get started, just a little bit of housekeeping. Today's session is being recorded, and we'll send the on-demand recording after the event. And if you have any questions during the presentation, please submit them using the Q&A panel, and we'll address as many as we can during the Q&A portion at the end. Additionally, the Traversal team will also be active in the chat throughout the entire session, answering questions and keeping the conversation going. So AI is accelerating software development at an incredible pace. Teams are generating more code and relying on automations throughout the development lifecycle. But while the code generation has evolved rapidly, production operations haven't kept up at the same speed. Engineering teams still spend significant time diagnosing failures, tracing root causes, and manually resolving incidents after deployment. So today we'll explore what happens when AI moves beyond writing code and starts helping operate software in production. And with that, I'm pleased to introduce our speaker. Joining us is Anish Agarwal, CEO and co-founder of Traversal. Anish is helping engineering teams rethink how they approach reliability incident response and AI-powered operations as software systems continue to grow in complexity. Anish, thanks for joining us. And with that, I'll turn it over to you.
Thank you. Thank you very much for having me. Very excited to be here. And for everyone attending, thank you for being here. A little bit about me. I'm a professor at Columbia University. I did my PhD at MIT in AI. All of my research has been in AI and ML broadly speaking. And I focus on a specific question within it, which is one of causal AI. So we've probably heard the phrase before, correlation isn't causation. So my research has been about how do you get these AI systems to learn cause and effect relationships from data? And that turns out to be really, really important for the problem of troubleshooting incidents and root cause analysis, as we'll talk about. So before I get into it, maybe stepping back, as we think about where AI has had some of the biggest impact in companies and in society, it's certainly in software engineering. That's the place we've seen the largest ROI. Now, as we think about software engineering and the software development lifecycle, broadly speaking, you can put it into three categories. The first part is system design. So thinking about how does the system get architected? What are the various components of it? The fun, creative work. The second part of it is actually building the system, which is software development. And the third part is once you've actually built the system, you've designed it, you've built it, you have to put it into production. Once you put your software system into production, I'm sure many of you here have had the pleasure of dealing with incidents and troubleshooting these incidents when something goes wrong and helping figure out how to fix the issue. And so these are the three core components of software development. Now, what has happened is that the software development part of it has become incredibly reformatted, rethought through because of these incredible tools like Claude Code, Codex, Cursor. And so they've significantly changed the amount of time people need to spend in software development because you basically tell AI what to do and it starts developing the code for you. But what about the other two parts of it? We want to be spending our time doing system design. That's the high creative, highly functional creative work that we would love to do as engineers. But what we're seeing with our customers and the industry as a whole is that most of the time is really being spent in troubleshooting. And so more and more time, rather than being spent in the creative work, is being spent in code review. And then once it hits production, how do you actually keep this code alive when customers are actually dealing with it? And the issue is that the gap is widening, which is making troubleshooting even more and more time consuming and resource intensive and painful. The reason is that the code is being written by AI. And so humans have less and less context about what is being written. And so the understanding they have of it is dropping. Second, these systems are getting way more complex because we expect magical things from AI as we build it. And so as the complexity goes up and the amount of understanding that humans have of the code drops down, that gap increases and it makes troubleshooting that much more painful, that much more time consuming. And this has real economic consequences. Production failures are costing companies billions of dollars, hundreds of billions of dollars. So if you just look at the global 2000, a conservative estimate is that it's over $400 billion lost due to downtime, which is a massive amount of money. And the part that is even more sometimes long-lasting is the reputational damage. So 41% of executives are saying that the downtime, rather than being detected by internal alerting systems or their own engineers, is first being detected by customers. And so when customers have this poor experience of your system being down, especially if it's a mission-critical system like payments or core infrastructure or healthcare or something like that, that reputation sits with them for a long time. And it's very, very hard to earn that back. It takes years to earn and can be lost in just one production incident. And the amount of time that engineers are being spent troubleshooting is increasing. It's over 7 hours now. So think of that. About 20% of the time of an engineer, which is one of the most valuable resources you have in a company, is being spent troubleshooting now. And so this is just getting untenable, and it's getting worse, as you'll see. So this problem of the amount of time being spent troubleshooting, the cost of downtime, et cetera, was already pretty bad or really bad pre-AI. We're seeing that with the advent of microservices in the cloud. The complexity has just shot up, but the amount of engineers that can actually troubleshoot has stayed relatively flat. And so the capacity for troubleshooting is remaining flat, but the complexity is going up. And now in this new AI world with tools like Claude Code or Cursor or Codex, it's shooting up like crazy, exponentially more quickly. And that produces more code, more telemetry, more alerts, more incidents. But the amount of humans who can keep up is the moment humans' capacity for troubleshooting remains flat. And so this gap is widening a lot. And we're already seeing that in a number of tools. Some of our most beloved tools that we use at the company, for example, GitHub, its production reliability has dropped significantly. And we're seeing this across a number, and this is just like a public explanation of this, but there's so many different companies where we're seeing reliability drop. They're having to spend more and more people on the problem to just keep up with the SLAs so that they're not fined, not to mention the reputational risk as we talked about. And the issue is that the way we think about troubleshooting, the software tools we have for troubleshooting, they're broadly in the bucket of observability. So we have these incredible tools like Datadog and Dynatrace and Splunk and ServiceNow. And all these tools, what they do is they help you visualize your system. They help you produce dashboards to give you a sense of how does my system look and feel. What they do is they help explain correlation. They help you see when something is broken, what else is broken at the same time, or that was close to it spatially. But it can't explain causation. And that's really the heart of the problem, which is what makes troubleshooting still so painful, so much downtime, so many people. And a really remarkable thing is that despite the fact that it doesn't actually solve the problem and show you causation, it is still the second largest software spend after your cloud spend. So it's a massive, massive spend, but you still are spending so many people on the problem, and downtime still seems to be going up. At the very least, it's remaining flat. And this problem of correlation and causation, it's not just our perspective. Two of the leading companies in the world are saying the same thing. So Google, in some ways, they formalized this idea of site reliability engineers in the Google SRE book, which is considered the Bible for SREs. They say that monitoring alerting enables a system to tell us when it's broken, but in a distributed system, it's often difficult to determine the cause of a failure. So again, they're talking about correlations and causation. And arguably the most important frontier lab in the world, Anthropic, where they're trying to automate the entire software development lifecycle using Claude Code, their SRE lead says the following, which is that we can't trust LLMs for incident response. The problem is its inability to step back and start discerning between causation and correlation. For us humans, it is hard as well. So what they're admitting is they can't use their own incredible technology for the problem of troubleshooting. And the reason being that causal reasoning is something that's really hard for these LLMs to do out of the box. And that's exactly what we're here to solve. Now, why is it so hard? Why is causal reasoning across a production scale system so hard? If you look at an incident, very typical incident that we would see with our customers, the incident would start because some customers are affected. Say they can't actually check out. They can't hit the billing system and check out for, let's say it's an e-commerce site. Now, when you go and you declare an incident and you actually go look at the data or you look at your production system, it looks like everything is broken. You have a sea of red because everything is emitting alerts. And the reason being that these software systems are complex networks. When one thing breaks, it spreads like an epidemic throughout the entire system. And so everything is looking broken at the same time. How do you figure out which one of these things is truly the root cause of the issue? And hunting through this is like going through a needle in a haystack with fake needles everywhere that are throwing you off. And this problem of trying to go connect the dots to go from the checkout API to the actual root cause, it actually happened to one of our customers, which was an expired TLS certificate. You have to make all of these causal hops through your data. And doing so takes hours, if not days. And the problem is that for a human or an LLM, the amount of context that they can look at is really limited. So they might be able to look at one team or maybe a few microservices at a time. But if you want to connect the dots across all of them, especially at the enterprise, they're producing about a petabyte of data a day at the very least. It's connecting the dots between these things with limited context that a human has and an LLM has makes it really painful. And that's where you have 50, 60 engineers in a war room trying to essentially build that shared context over hours, if not days, to build that shared context in a sufficient way so they can get to the root cause and piece it all together. But it's still really, really painful because of the limited context, the fact that everything is breaking, and the scale is just too large for any team to put in their heads or have process. Now, we believe that there's a better way of doing things. And our vision is what we call self-driving production, which is, can you actually take the problem we talked about of troubleshooting and all the manual work in there and make it fully automated? And we believe that a good framework for thinking about it is through self-driving cars. And so when we have self-driving cars, you have different notions of autonomy, from L0, where the car is fully being driven by a human, to L5, where it's fully driving itself, like something like Waymo. That same framework can be applied to troubleshooting and production operations as well. So L0 would be fully manual troubleshooting. We are debugging via war rooms and dashboards. L1 is where you start doing some sort of rule-based automation, where you have like static alerts and runbooks, and you kind of execute those pre-existing steps when an incident happens, but it really breaks anything new. This L2 is where you start using AI to help automate some parts of your system. So you're using LLMs to summarize a Slack channel, or say you have a complicated Splunk query you need to write. You know what you want to write, but writing is really painful. You can get an LLM to go write it for you. So you're still in the driver's seat, but an LLM is kind of a co-pilot helping you do some of the menial tasks, but you're very much driving it. L3 is where it starts getting somewhat agentic, where you have an agent that's able to troubleshoot for a specific part of your system, say just the database issues, just networking. And so when you have limited context, as we talked about, then an LLM can do something, especially with help from a human, but it's not able to go troubleshoot across the system. Okay, and so cross-layer root causes get missed in this layer. Now, the real value add comes when you get to L4, when you can autonomously troubleshoot across your entire system. And as we talked about, go from the checkout API to the expired TLS certificate and do the 10 to 15 hops throughout your system. And that's where we are at with our customers. We can actually help them autonomously go from a very high-level symptom to the true root cause and make all of those hops. The end goal, nirvana, is really self-driving production, which is where the second the code gets written, you have a system that is scanning it for reliability issues. Once it hits production, it is scanning for every time there's an issue. If there's an issue, it actually heals the system autonomously, pushes that healing in staging, pushes that fix into production, and the system kind of just works in a full loop, keeping it stable. So from L4 to L5 is where you have to go make autonomous changes to the system. We do that with some of the customers we've been working with for a while, and we certainly have begun to do this at Traversal itself. The real difficulty is going from L3 to L4. L4 to L5 is really about change management, where you have to get people comfortable with the AI system writing code in your system and fixing things into production. And it's more, just as much as it's a technology issue, it's really a change management issue, and we're already making good headway with some of our early customers. And I think the proof is in the pudding, where some of the largest and most complex production environments in the world run on Traversal. So these are some of the customers we work with that we have listed here. And the amazing thing is that with these customers, we're finding that we're able to get to really high levels of accuracy at scale, so at petabyte scale. So, at the scale of like 2 trillion logs, 1 trillion span, billions of metrics, millions of events, so on and so forth. And we're able to actually get to a root cause, which is with 80% accuracy, where you're telling it the specific remediation steps in under 5 minutes. And that's really what we find incredible, is we're able to do this at some of the largest companies in the world at scale and get a really good answer in a really short period of time, and really proud of that fact. And the value add has been really, really clear to see. There's this issue right now with AI where people are what they call token maxing. We're just using AI to do a lot of AI slop, for lack of a better word. The good news is, in the problem of AI for site reliability engineering and production operations, the ROI is super, super clear, right? So we have a collection of different products we have. For example, alert intelligence, which is actually helping you figure out from the alerts which of these alerts combinations are going to become an incident and actually preventing incidents from happening. So that's the MTTD metric. Then you have incident RCA, which is around, can you troubleshoot these incidents and come up with the root cause? Self-healing is actually healing the system. Chat with prod is all those little operational toil that you have every day when you're like looking for dashboards to get a sense of your system, that we call chat with prod. And then code resilience, which is actually, can you make the code resilient before it even hits production? And we're seeing massive reduction in MTTR and MTTD, 85% plus, which is something we're very proud of. The remediation accuracy is really high, so it's 82% in terms of accuracy, where the accuracy is defined as giving you accurate remediating steps. And it's like 8-figure plus in terms of savings in the tens of millions of dollars for our customers, just in the first year. And hundreds of hours of engineering hours have been saved because when customers are starting to work with Traversal. And so the ROI of using Traversal is very clear and tremendous, and it's measured in these very clear, tangible ways that people are very used to. And I said, all of these things can be tied to clear ROIs, for example, MTTD for alerts, MTTR for incidents, MTTR for self-healing, the mean time to understanding, and also just the engineering hours being spent, and also the number of incidents. So everything we do has a clear ROI associated with it, a KPI that customers can measure and bring back to their own team and being like, this is why we're using Traversal and why they're spending more and more time with us and investing more in the relationship with us. And here are some use cases of how we use it. So I'll walk through a few of them. So we have alert intelligence. So this is something we do with like one of our customers, Pepsi, where they have hundreds of backlogged alerts, high priority alerts, and just each of them take 20, 30 minutes to troubleshoot. Now, to get to the answer, it can take a long time. And when they actually have incidents, when they do run a postmortem, they find that most of the incidents, there was a combination of alerts that have told them what the issue is. They just never had the time to go through them. And as a result of working with Traversal, they're now identifying the alerts that are going to become an incident, and they don't have the backlog has been significantly diminished. And so there's hundreds of hours of engineering hours saved because of this, and 35% fewer incidents because it's automatic triaging. And so now, rather than customers seeing the issue, their own internal systems are catching the issues and they're fixing the issues before it becomes a real problem, with the reputational risk and the cost of it becoming a real incident. Similarly, with one of our financial services customers, we see before Traversal, this is the type of issues they would have, where alert was fired, would become an incident bridge, would take about 6 minutes. And from there, it would be essentially a huge amount of time. It could be like, in this case, 63 minutes. There were 5 different teams paged because no one really knew who the issue was. And it was like 58 engineers in that room, all of them kind of trying to figure out collectively what the issue was, as we talked about, because each team has limited context. You have to bring all these collective teams together to figure out what broke. And there were 3 key things that they were identified during that time to go heal the issue. One is that to fail over traffic to a different region. They had to go flush a specific Redis database, and they had to go flush certain pods and recycle them. Once they did that, it actually healed the system. After Traversal, they had a very similar issue show up, and now the time was dramatically reduced. Rather than taking 63 minutes, it just took 25 minutes. And rather than 5 teams, it just took 2 teams. And rather than 58 engineers, it was just 5 engineers troubleshooting it. And so there's a massive decrease in the time and the amount of resources it took to troubleshoot these incidents. And you can see that in that time, the Traversal, once it began, in a very short period of time, it told them the key steps, which was failing over to a different region, flushing a Redis database, and identifying the pods that needed to get flushed or restarted. And so because they identified these key things, there was way, way fewer engineers required, and they could spend most of their time healing the system and verifying that it was healed. And so this is really what leads to massive amounts of savings for these customers. Same thing with other customers, where we actually heal the system, where before Traversal, there were all these different things that to go troubleshoot, figure out what the key symptoms were, and then actually heal the system in that specific way where the root cause was identified. Now, after using Traversal, the second the bridge was triggered, we automatically heal the system. Forget about any engineers getting involved to go figure out how to heal the system. Traversal just found the fix and executed the fix. That's what I mean with some of our customers. We're actually in L5, where it's led to massive reduction in MTTR and tens of thousands of hours of support engineering hours saved because of this. And again, with another customer, where it's now the chat with prod part of the system, like SKU that we have, where all of these different operational questions that they have every day, all of that is now being, rather than going to like 10 different observability systems to go find the answer and create the answer, they just ask one natural language question in Traversal and it gives back the answer. And here's like some work we've done to go identify when these operational toil questions where chat with prod comes up with an incident investigation, just operation, which is like, for example, can you help me explore my observability, track customer journeys, asking follow-up questions when you have a live root cause incident, or when you have like operational knowledge questions like, hey, who owns the payment orchestration, just to figure out when you have these large complex systems, who owns what, general understanding of the system. So when you have like engineers who are junior, getting them to understand the system quickly so they can troubleshoot more effectively. So general Q&A, knowledge management, all those kinds of questions, and also change. So a lot of issues get caused by change, and so you want to know before you deploy a change and after you deploy a change, what kinds of issues it can cause or has caused. And so doing that kind of problem management, doing the validation of a change, post-mortem analysis, doing things like, hey, if I deploy this change, what's going to happen to my system? All those kinds of questions can now be answered in a very natural language way, versus you having to go to 10 systems and taking 2 hours. And that might be for an expert engineer and might be like next to impossible for a junior engineer who doesn't even know where to look. And so this has led to like thousands of queries a day just in May for these kinds of chat questions. And there's like 90% speed increase in these questions and hours saved per week per team. I said the last thing that's really interesting is that we actually help make code more resilient even before it hits production. So all of the work that we're doing, we release it as an MCP server, right? All the various parts that make Traversal, the agentic SRE platform. And you have all of these coding agents like Claude Code or Cursor or Codex that actually call the Traversal MCP as they're writing code or as an engineer is writing code to make their code more production aware to begin with. And that's been incredible because now we're really closing out the entire software development lifecycle in that view towards self-driving production, where the coding agents call upon Traversal to write it to make it more resilient. Once the code hits production, if there's any sort of issues, Traversal then finds what the issue is, recommends a fix, and then you can kind of hand that back to a coding agent to go deploy the fix. So it all is working in a full loop, and that's saving massive savings in incidents and also just engineering hours. And to solve this kind of issue at scale, as you talked about at some of the largest companies in the world, there's 5 criteria that we believe you need to go think about. So whether you go think about any vendor you want to work with in the space, or if you want to build this yourself, here's our advice or here's our guidance. And the 5 questions you basically have to answer to solve this issue. The first is, can you look at all of your production data in your system without gaps? Because if you can't look at all the things in a seamless way, you're only going to get half an answer, and you won't be able to do all those jumps from like checkout API all the way to an expired TLS certificate. The second is, can you reason about your data at scale? Because again, this is petabytes of data. Can you reason about this data at scale without blowing up your LLM costs or your network egress costs? And that can be a huge amount of money, because just running an incident through that much data could cost you thousands of dollars if you don't know how to like compress the data in the right way. Third is it able to give you a live representation of all of the relevant entities in your system and do that in real time without needing a bunch of engineers to keep mapping it? Can it have fidelity of your actual live system with all the entities and how they connect in real time? The fourth is, this is a really, really important one, is it getting smarter by itself, or does it require a team of FDEs, like forward deployed engineers, to keep tuning the system, either from the vendor side or the user side? Because if you have to basically have a team of FDEs constantly tuning the system, then you might as well do what you were originally doing, right? It doesn't actually make the system any better. You're just kicking the can down the road. So it has to learn how to get smarter with minimal need of engineering effort from both the vendor side and the customer side. And the fifth one, which is really important, is it actually able to identify root causes, not just for a given team, but far from the initial symptom, and is it able to do so in minutes? And we believe that to have a really effective solution in the space, you have to be able to answer all 5 of these questions really effectively. And the entire Traversal platform is really designed for this. So we have the agentless data capture, which really thinks about the problem of like, can you look at all of your data without gaps? So we don't install any sort of agent on your system as read-only access, and we're able to talk to these systems with a click of a button to your melt telemetry, your source code, your deploys, your run books, your historical incidents, your Jira. We all just need, and it'll find all this by itself. It does so with read-only access to your systems. And we can do so with a push-based and pull-based way of looking at the data. The second one's really important, which is, can you actually talk to all this data at scale without blowing up your costs? And that's where our AI native compressor does that. So it's able to actually find the right compression of the data with basically no loss of signal. And that's a key part of the technical work we've done, is how do you actually find a way of compressing the data? And we're finding it's 1,000-to-1 compression. So if it's about a petabyte of data, we only need to store about a terabyte of data on our systems, and we're able to effectively get to a high levels of accuracy. And so that compression is crucial for us to be able to save on LLM costs and also networking costs, which becomes really, really important as you bring this to scale within a company. Once you do that, can you actually build a live representation of all the elements in your system? That's where the production wall model comes in, which is really the crown jewel of what we're building, which is a map of a mine. It mines all the different entities in your system, and then it's able to essentially, with mapping all the entities in your system, find the way they connect, what all the representations of them are that is particularly agentic readable. So it's readable by LLMs and an agentic system. And the knowledge bank is all of the unstructured information in your system that's not available to the telemetry. That's really what gets structured here. And so rather than a human having to go tune the system, this is able to go learn by constant feedback, by interacting with the system, and by hunting down all of the different unstructured information in the system. So it's like a constant self-improving eval system, and also looking at all of the unstructured information in the system. So the knowledge bank plus the production world model become the right representation of production for an agentic system to search through. Now, the agentic harness that is searching through all of that, that's what we call our causal search engine. And that's really what is able to identify root causes far from the initial symptoms. And that's the harness which is able to figure out if something is spurious correlation or truly the root cause. And so that agentic harness working on top of the knowledge bank of the production world model is really what it creates and unlocks the enterprise capabilities that we talked about earlier, which is alert intelligence, instant RCA, self-healing, chat with production, and code resilience, and with the case studies we talked about earlier. And when you put all these things together, especially the production world model plus the causal search engine, that's really what allows you to hop through the system in an effective way at scale without blowing up your cost and getting to a really accurate answer far from the initial symptom. As I said, our future of what we're building at Traversal is self-driving production. So getting our customers at least to L4, all of our customers are at L4, and really getting to L5. And the gap from L3 to L4, which is going from a single issue, troubleshooting a single team to troubleshooting across your entire production environment, that's where you need the causal search engine and production world model. That is what lets you get to L4. And with some of our customers with L5, as we talked about, and that's our goal to bring all our customers to L5 essentially within this year. Thank you very much. I appreciate your attention.
Well, Anish, that was very insightful. I love how you are saving people time and money. So I love the product. So now it's time for a Q&A portion. To our audience, as a reminder, you can submit your questions using the Q&A panel, and we'll get to as many as we can. Right, so first question that we have here says, why is applying AI to incident resolution different or more difficult than applying AI to code generation?
That's a really good question. There's a few reasons. One is these AI models have not been trained on the type of telemetry data versus coding. There's so many great open source coding libraries. So you can learn a lot from these open source systems, and you have a lot of labels of like how people write code. You don't really have that. You don't have these systems that are trained on like billions of metrics and traces and config files as much. And so there's not that inherent knowledge of these systems in the model weights. Second, coding is something that you can have an individual do, and you can kind of see the steps, and it does a good job. Troubleshooting is something that we're not inherently good at as engineers. And so trying to emulate what engineers do with troubleshooting is actually the wrong kind of model learning framework. And so that's another reason why you don't really have clean labeled data sets to train these models on, because trying to copy what teams of engineers do is actually suboptimal. That's the second thing. Third is just the scale of the data. So these trying to troubleshoot an incident, like for example, just to give you a sense, just the amount of tokens we are processing for a given incident to troubleshoot, and this is already compressed, is multiples of times the context window of what it would be to put the entire Harry Potter series in there. So it's massive amounts of like tokens that you need to be able to consume and be efficient about it. And that's after the 1001 compression. And so just the mere scale of the data is so large that you can't just throw it into the context of an LLM, nor are these systems good at reasoning about it. Fourth is that causal reasoning is something that's really hard and not something that these LLMs are inherently good at. And that's something you have to build into these systems through the right agentic harness. And so that's why with these reasons, it's really hard for these systems to do it out of the box. And you have to build specialized solutions such as Traversal to get to the level of accuracy and speed that will actually delight engineers.
So let's follow up on that a little bit. So why have we made so much progress for code generation, but not the other way around?
The other way around being for troubleshooting of incidents?
Yes.
Actually, I'd say there's a lot of progress that has been made. I'd say there isn't like an open source solution as we talked about, because these LLMs are not inherently good at it. But as you're seeing with some of the people we work with, there's massive ROI we're already seeing with our customers. And it's really just a matter of us getting to more and more people. I think the product is in an incredible place now, and the people we work with are getting massive ROI from it, and now it's just a matter of getting to everyone. I'd say a second part of it is that now that the coding agents are getting more mature, the amount of complexity is going up. And so now I think, as we're seeing this with the customers already, but I think this will be more widespread, but the need for something like traversal is going to spike up. And I think we're here to meet the moment.
Okay. So we go to the next audience question here. What specifically has to be true, technically and organizationally, for an enterprise to make the jump from L4 to L5? And what's exactly holding them back right now?
It's a great question. So the one is you have to obviously have a high enough level of accuracy. And so that, as the system learns in a short period of time, it can get there. Now, so that's like table stakes in terms of technology, but I believe that's actually very much possible. And the way we define accuracy with a lot of our customers is if you're able to give them accurate remediation steps, right? That's how we define whether we got to an accurate incident RCA. Now, the question is, how do you go from there to L5? We found it's really a change management problem. So people don't want to have an AI just autonomously writing code, especially when something is broken in production and just deploying in production. And so you kind of have to take them on a journey. The first step is giving them accurate remediation steps so that any engineer can go execute the steps and they see if it effectively heals the system. The second part of it is then you put those remediation steps behind, let's say, a button, right? Then an engineer has to go click on the button after they verify it. Once they're comfortable with that, third is where you kind of give the system like a whitelisted set of commands, like here are like 10 things you should do that an AI is allowed to do to go heal the system, like pulling back a commit, rescaling some part of the infrastructure, recycling some pods, whatever. So some set of commands are not going to hurt the system, and so you give it these kind of like quotes unquote small runbooks that an AI can go piece together to go heal the system. And after that, you probably go to full self-healing where you give it a sandbox and it can experiment and do things on its own. So I think it's on a journey you have to take customers on, and with the early customers, we're further along in the journey, and then for the customers that have come more recently, we're giving them the self-remediation steps. Soon we'll put a button there. So it's really a journey.
Yeah, that definitely makes sense. We have another question here. It says, if self-driving production becomes the norm over the next few years, how does the role of the SRE actually change?
That's a great question. The way I think about it is that I use the analogy of healthcare. And so I think SRE, the work of an SRE and observability is very tied to healthcare. It's really about the healthcare of software systems. And so if you think about healthcare, like you think about like the Maslow hierarchy of needs, you have a heart attack. You got to go fix that right now because you're having a heart attack. And then the second stage is where you have some chronic conditions. Your knees hurting, you can't sleep that well, whatever it might be. And those things are like 1,000 paper cuts that are always affecting your general quality of life. If you can solve both of these things, then you kind of think about like health hacking, where you think about longevity and like really improving the quality of your life and in an active, intentional way. I think a similar kind of thing can be thought through in the world of SRE, where dealing with incidents like Sev zeros and Sev ones is like having a heart attack. The alerts you have every day, the small little issues that are constantly happening in a system, that's like having the chronic condition that's affecting you. And only when you deal with these things, then you have the time to go think about the resilience of your system and building more resilient systems for the next 5 years. And that's the equivalent of like health hacking, right? And I think the way SREs currently function is like they have 3 heart attacks a week. They have 5 chronic conditions, and they never get to think about the long-term resilience of their system. And so what we believe is that if we do our job correctly, then we can deal with the heart attacks and the chronic conditions, and SREs can spend really their time in the creative, high-impact, long-lasting work, which is about building more resilient systems for the future versus like getting burnt out with these incidents at 3 a.m. every night. And so that's our vision for how we believe. And also engineers. I think engineers are spending way too much time not building, but actually reviewing code and troubleshooting. I think, again, all these people can now spend their time on like high-order exercises, like designing better systems.
So kind of staying along that same vein of thought, are we headed towards fewer SREs or different SREs doing higher leverage work?
I think we'll always need SREs. I think it'll just be about higher leverage work, in my opinion. I think it's about doing work that is long-lasting work that affects the company for a long period of time. I think SREs will also, this is a bit of a trope now, but I think SREs will spend a lot more time managing agents, right? So everyone will kind of have like almost like a super intelligent AI SRE that is giving you context about the entire system, and then you have like these smaller agentic SREs that go complete tasks for you. And so you have both of these things that give you full production in context, because you can't keep all of that in your head at scale, and then like simple SRE agents that are doing the tasks that you want. And so I think you become a manager, and you also get to think about long-term tasks.
Excellent. Well said. Well, unfortunately, with that, we are out of time for our Q&As today. But if you didn't get your question answered, the Traversal team will follow up afterward. Now, Anish, before we wrap up, I want to get back to you just to see your thoughts about how people can be engaged and how people can continue to just have more of the in-depth conversation.
Absolutely. I think the best thing to do is we'd love to show you the product. I think the proof is in the pudding. And so as you'll see probably in your screen right now, we have a link to book a demo. And you also have that link on our website. So please visit our website and book a demo, or click it right here. And we'll be certain to follow up with you and see how we can help your organization, yourself, in building more resilient systems without having to wake up at 3 a.m. at night. So please do book a demo with us.
Excellent. Make sure you book that demo. And again, to the audience, thank you everyone who joined us today. And remember, keep an eye out on your inbox for the on-demand recording. Once again, I'm Caleb Kinchlow, and we hope to see you at our next future D-Zone webinar. Take care.
Thank you.